All right, for the PLP, we are now on video 5.4, which we're switching gears this time. We've been doing surface area, which means we've been measuring the area of each of these faces and kind of adding them all together. Now we're switching to volume. And volume would be if I poured a liquid inside here, how much would fill it up? So how much basically air is inside this? How much space is on the inside? So we're not measuring each of the outsides and adding those together. We're finding the total of the space that would fill the inside. So that is what it means by volume. All right, here is the formula for volume. We're going to take 1/3, or we're going to take the whole thing and divide by 3, because we know that if you multiply 1/3 times base times height, it's the same thing as taking base times height and then just dividing the whole thing by 3. And to be honest, I'll probably do this because I don't like pushing 1, A, B, C, 3 in my calculator. I'd much rather find the base, multiply by the height, and then just click divided by 3. So remember, 1/3 being multiplied is the same thing as divided by 3. Some of you might notice, why is the B capitalized for base and the H is not? There is a meaning behind that. So you guys definitely need to know this for when you get into high school in geometry class. So it's not just the base, like one number. The area of the base is why it's a B capitalized. So we're taking the whole area of the base. A lot of kids might write, oh, the base is 20. That's the length of one side of the base. The other length is 11, and I need the whole base that it's sitting on. That's why it's a capital B, because there's a little bit of work you have to do to get that base number. It's the whole area calculated of the base that goes into this B. Then we're going to multiply by the height, so however tall it is from the center, and then we're going to take that and divide by 3. And here's a little tip. Anytime you're doing volume of something that goes to a sharp point, like if it goes up to a point, you're always going to take whatever it was and divide by 3. So that's what makes it go to a point. You're dividing the bigger bottom part by 3 to make it kind of go to a point. So later when we get into what else goes to a point? Oh, cones. You will also be dividing by 3 on cones. Okay, so let's do this. So all we're going to do is capital base times height divided by 3. But to get the base, we have to calculate this whole area of this entire base. This whole thing's the base, not just the 20. It's the 20 times 11, because the area of this base is a rectangle. So in order to find the base area of a rectangle, we have to do length times width. So 20 times 11 will give us our capital letter B base. So we have 20 times 11. Then we're going to multiply by the height, which is 21. And then we're going to take that whole thing and divide it by 3. So this is just going to be easily done in a calculator. So take your calculator, and we are going to do 20 times 11 times 21, and then I'm going to take that whole thing. I'm going to go ahead and push equals first. I know some people's calculators, it doesn't matter. You can go straight to a divided by 3, but I like to click equals first just to make sure it's doing it right. And then that answer divided by 3 is 1,540. So 1,540. And I don't know what the unit is. It might have been inches or meters or centimeters or whatever, but whatever the unit is, I'll just call it units. It would be cubed this time because we're filling 3-dimensional space. So since we're filling the inside and we want to know how much a 3D volume is, that's why it's cubed, because it's cubic space. It's filling the inside. So again, I don't think you even need that. I know when you get to Delta Math, you just need to type in the answer. All right, let's do another one of these with a rectangular base. So the base is 8 by 6, so we need to multiply 8 by 6 times the height, which in this case is 10, and then that whole thing, since it goes to a point, we're going to divide by 3. So in your calculator, 8 times 6 times 10 equals divided by 3. That is 160 cubic units. So 160 units cubed is how that label looks. Again, don't care about the label. Okay, It's really important that you pay attention to the next two because these do not have a rectangle base. So we're still finding the volume and it's still a pyramid, but this time the base is not a rectangle or square. What shape is the base? It's a triangle. So a triangle's base is not just length times width. If you remember, the area of the base of a triangle is 1/2 base times height. So this one's a little tricky because in order to make that capital big B, it's all of this. And then we're going to multiply by the height of our pyramid, and then we're going to still divide by 3. So in order to get this capital big B, it's doing all of this. So be sure you pay attention when you get to your delta math of what the base looks like, because if it's a triangle, you have to do an extra step in here and half it. Okay, so it is 10 by 17, but because it's a triangle, we're going to do times half. So 10 times 17 times half, or you could put the half at the front if you want, it doesn't matter, 1/2 base times height, 1/2 base times height. And then we're going to multiply by the height of the whole pyramid, which is 14, and then we're going to divide by 3. So there is an extra step when the base is not rectangular. Okay, so I'm going to do 0.5 as my half. So I'm going to take in my calculator 0.5 times 10 times 17 times 14 equals divided by 3 equals. Okay, this gives us a weird decimal, but that's okay because I didn't read the instructions until now. It says round your answer to the nearest tenth. So we need only one number after the decimal. So it's going to be 396 point something. And so you have to look at this number and decide if you're rounding it up to a 7 or if it's going to stay 6. And since the next number after it is 5 or above, we're going to give this a shove and it's going to be 7. So 396 is going to be rounded up to a 0.7, and again, that's cubic units because it's 3-dimensional. Okay, let's do at least one more of those with the triangle base. I'm afraid you're going to get to that and forget about the half. Okay, so here's another triangle base. We have to do 1/2 the base times the height of the base triangle. So that's a 15 by, looks like it's pointing to this, which is 17. So 15 times 17. So 15 times 17, and then times the height of the whole pyramid, which is also 17. And then we'll divide the whole thing by 3 because it goes to a point. All right, so here we go. 0.5, which I'm using for my 1/2, times 15. Times 17, times 17 again. I'm going to do equals, and then divided by 3 equals. And that one already was rounded to the nearest tenth. So that one is nice that it did it for me. So 722.5 cubic units. Okay, I would like for you to try the next two on your own. And definitely check, oh, if you didn't get to see that answer, there you go. Definitely pause the video and then let the video play, or at least fast forward and check and make sure your final answers are correct on these two. Remember, you do them differently because this is a rectangular base and this is a triangular base. So go ahead and try these, push pause, and then check back. Okay, so this one, I love the rectangular base because it's a little bit easier. It would just be 18 times 8 times 17, and then divided by 3. So in your calculator, 18 times 8 times 17 equals, divided by 3 equals a whole number. So I got 816. So 816 cubic units is the answer to that one. Remember, triangles are a little trickier because the base of a triangle needs to be halved. So I need to do half times 15 and 9, or 9 and 15, the order doesn't matter, times the height of the pyramid, which is 12, and then divide the whole thing by 3. So 1/2, 15, 9, 12 all get multiplied. and then I divide by 3, and that came out evenly too. So 270 cubic units. All right. So go ahead and try your delta math now. Just be really careful that you check out to see if one of them is a triangle base versus a rectangular base, and we left you a little room, not much, but a little room to work out your problems down here.